So this next set of videos is going to be our introduction to operant conditioning, its procedures and concepts at sort of the basic level, and then we'll spend the next few topics really diving into that stuff in much more detail and seeing the applications at large. But to start, let's just think about one thing that makes operant conditioning kind of special relative to respondent conditioning. So animals that can learn, that have a nervous system capable of learning, they don't just follow instinctive behaviors. They don't have a set of behavioral routines that they're stuck with. Their behaviors adjust to the environment's contingencies and can differ from other individuals of that species just based on their own past experience, their life experience so far. For example, dogs don't instinctually play dead, like this cute dog here, but they have brains with enough built-in flexibility to be capable of learning new behavioral routines and eventually doing behaviors that they wouldn't sort of naturally do based on the environment and experience that they've been exposed to. So to understand how brains learn new behaviors, we have to start thinking in terms of contingencies. A contingency is an if-then statement. If X, then Y, sort of X predictably leads to Y. From the dog's perspective, over time, it's learning things like, if I sit when the owner says sit, that's a behavior, then I get a treat. That's a stimulus as an outcome, right? That's something that happens when I do the behavior. In some sense, a human worker over time is learning, if I show up for work and do the work, then I get a paycheck. So the term contingency is because Y only happens if X occurs first. So Y is contingent on X happening. Basically, no treat for the dog unless you sit. No paycheck for the worker unless you show up and work. So setting up a contingency is a good way to get dogs to sit or people to work or any other behaviors you want. In the notation we've been using, a contingency could look like this. A behavior R leads to a reinforcer, meaning a stimulus that's reinforcing. So we have our S for stimulus and that little superscript R just to tell us it's a reinforcing stimulus, like a good thing, something they'll enjoy. Let's see a contingency sort of in action here. So I'll play this little video of adorable cats. So the human has set up a contingency for these cats. If they do the bell pressing behavior, then they receive a treat stimulus. But notice they don't get the treat stimulus if they don't do the behavior first. So that's what we mean by contingency. You have to do one thing in order to get the other. And predictably, if you do that thing, if you do that behavior, the stimulus will show up. So in our notation, we previously added that SD at the beginning, standing for discriminative stimulus, meaning the context or signal, the SD, sets the occasion for R being reinforced. SD tells the organism that the behavior leads to stimulus contingency is active right now. So this is our contingency. The SD, the discriminative stimulus, says, hey, right now doing the behavior will lead to the stimulus. I'm in that type of situation at the moment. So let's see some examples of behavior you can get with operant conditioning and then apply some of that terminology to it. So here's some fairly impressive tricks from rats learned with operant conditioning. You'll notice she's making the treat stimulus contingent on them doing a certain behavior first. Behavior leads to treat reliably. They're pretty impressive. Rats are really smart, really social, can be highly motivated, both by food and love. they're married. I don't know why you're trying that trick. That'd probably get annoying after a while. These are Canadian rats, by the way. So when she says, "Come, Shadow, Shadow, come," that's a discriminative stimulus, an SD, that's signaling to the rat that the whole approach leads to treat contingency is active. So hearing that sound sets the occasion for approach behavior. At other times, approaching doesn't get a treat. That means it also, when you say sets the occasion, it means it makes the behavior more likely. So in that context, when that discriminative stimulus is present, it means probabilistically we're more likely to see that behavior at that time. Likewise, setting out the familiar chair at the familiar distance, sort of tapping it and saying jump, that can act as a discriminative stimulus that sets the occasion for the rat jumping, because it signals that the jumping leads to treat contingency is active. At other times, when the SD isn't there, when there's no discriminative stimulus, when the chair is not there, or she hasn't just said jump, jumping doesn't get a treat. In other words, if the rat just jumps around when the owner's not in the room, the contingency isn't active, and no treat shows up. And the brain can pick up on that. So discriminative stimuli, they don't elicit 100% sort of force the behavior. They make it more likely because it signals that the reinforcement contingency is active. So if the rat happens to want a treat right now, like if it's hungry and motivated, then it's more likely to do R right now. This only works because of a past history of reinforcement when that SD was present. So whether a behavior R happens right now or not is determined by past experience with the SD and the SR. And based on the SD being present right now, that sort of kicks in that past experience and makes me more likely to do the behavior right now. So as we learn, our brain is picking up on rules of how the world works. We're rarely just learning the RS contingency, the behavior outcome contingency. We're also picking up on signals about when that contingency is or is not active. This is often called differential reinforcement. Like we might purposely set things up so that when a green light is on, doing the behavior works. It leads to the stimulus that's reinforcing. But when the red light is on, doing the behavior doesn't work. The good stimulus doesn't show up after the behavior. The green light serves as an SD, a discriminative stimulus, setting the occasion for the behavior we want. Tells our brain this is a good time to do R. But the red light serves as an S delta. That little triangle sign is a delta, Greek letter delta. It signals the contingency, R leading to SR, leading to our reinforcer, is not active right now, that the behavior won't be reinforced right now. So with enough experience, the S delta being present makes the behavior less likely. By understanding that simple mechanism, you can actually use operant conditioning to create really complex behaviors or sequences of behaviors, even ones that the learner wouldn't naturally do on their own. For example, imagine you want a rat to play fetch, like we saw in the video. So you might set up a contingency where the rat will get rewarded when it does the fetch behavior. Great, except rats don't naturally do that behavior, so you've set up this contingency, but you never have a chance to actually reinforce it, and the rat never has the opportunity to learn that your contingency exists. Damn. Well, there's a trick we can use to get there through steps. A common procedure we call shaping. So shaping is the differential reinforcement of successive approximations toward the behavior you want performed. Meaning you start with a contingency that rewards just a first step toward the behavior you want. Then later you change to a contingency that rewards something a little closer to that final target behavior you want. And you keep doing that until at the end, finally, you're rewarding the actual target behavior you desired. So, for example, to get our rat to play fetch, you might start with a simple contingency based on a behavior the rat will already do naturally, something that occurs as part of its normal repertoire of behaviors, even if just occasionally or randomly. So for a while, the rule is maybe you give a treat only when the rat faces the ball. Because, a rat just wandering around its environment, sometimes it'll happen to face in that direction. You just got to be watching and really quickly give it a treat every time it happens to face in that direction. And its little brain will eventually notice, like, oh, it's when the ball is in that direction, when I can see the ball, when I'm facing towards it, that's when the treat shows up. So it'll start to kind of face towards the ball a little more often. Then, once it's doing that consistently, once it's learned to face the ball for a treat, you change the rules. You institute a different contingency. Give a treat only when the rat approaches the ball. And then once it's learned that, once it's consistently approaching the ball, once seeing the ball leads to the rat going toward it to get a treat, then you switch to a new contingency. Get a little closer to your final goal of playing fetch. So maybe the new rule becomes that you're only going to give a treat when the rat touches the ball. It has to make physical contact. After that, you might change the rules to only when the rat picks up the ball, and then only when the rat carries the ball toward you. Voila, you now have the rat doing the behavior you want, letting you reinforce that behavior, making it more likely when you present the ball in the future, even though that's something the rat wouldn't have done on its own before you did the step-by-step shaping. Here's an old video where B.F. Skinner has shaped some pigeons to play Pong.
The two pigeons are at either end of a small ping-pong table. One pigeon pecks the ball as it comes toward him and knocks it toward the other pigeon. Other pigeon pecks the ball back across the table. If it goes past one pigeon, the other pigeon can eat, and if it goes the other way, the other pigeon eats. So that there is it's a real game. The pigeon is reinforced for a cross-court shot if that is what gets the ball past his opponent.
So think of the steps that went into this. First, you have to get the pigeon to care about the ball at all, which may not be natural for pigeons. Then you have to get it to peck the ball. Then you have to get it to peck the ball in a particular direction when there's no opponent present. Then you finally end on a contingency where the only way it gets a treat is if it pecks the ball in that direction such that it goes past the opponent. And at that point, you've trained the pigeon to play Pong. Here's an example of shaping in a fish. So we'll see sort of the steps here. So you might feed a fish with a little feeding wand. You'll see here it pops out, some little bubbles will come up, but a little treat actually comes out every time it opens up. So first the fish has to associate the feeding wand with the food itself. That's actually respondent conditioning. It's a stimulus-stimulus association when it realizes that wand comes with food. Then we set up a contingency that say it has to approach the wand. So it learns that swimming toward the wand is what leads to food showing up. We only open it up and give the little treat when it approaches the wand. That's operant conditioning, because now it's learning a behavior leading to a stimulus. Then you make the contingency be that it has to swim through a hoop, maybe a big hoop at first. And then finally, once it's doing that consistently, you can change the rules, change the contingency so that it has to swim through a little hoop, right? So you can take that big hoop and make it smaller. And again, only rewarded if it goes through the hoop, not around the hoop. You can actually buy these little kits online, and from there, it's not much harder to get a fish to push a ball through a hoop or many other tricks like that. So you can get fish playing sort of basketball or soccer, you might call it. So that's shaping. All right, I think that'll be it for this video. In the next video, we're going to cover the most common types of contingencies, not just for reinforcement, but also for punishment. So I'll see you there.